let's cut to the chase and let's talk about Android KTX. What is KTX? KTX is a set of libraries to make the Android APIs more accessible for Kotlin developers. A picture worth 100 is worth more than 100 words. Let's see a picture and see if you get it. This is KTX. As you see on the bottom, the meat is the Android APIs. The guy here is the KTX libraries, and as you can see, he's putting syntactic sugar on the on the Android APIs. And let's see. And why is useful? Because it makes our code easy, clean, and easy to read. As you can see, these first lines are from KTX. It's easy. This is an object view, and we are asking, it is visible? We are doing something. It's not. We are doing something else. And the other thing is the traditional APIs. We have a visibility property, and as you see, it's an integer, and we have to check with a constant. It's not also readable. Let's see another example if you don't believe me. Okay, also helps KTX help us with discoverability. Maybe you don't know this class, test_util, and this method is digit only. Don't get worried, me neither, because this is a test. This is a utility class, like many other classes like that. There are many other classes like that on the Android API, but there is no easy way to find them. And KTX help us with that. Why? Just in my case, when I don't know something about an object, I just put a dot in front of after the object, and I can see everything this object can do. And it's the same with KTX. Using Kotlin extensions, you can find the functionality that you can apply to this object without memorizing utility classes. Let's see another thing. Also, you are thinking, okay, this sounds great, but it's going to add more space to my APK. No, it's not, because it has a small footprint. As I told you, it's a set of APIs, but they are segregated by feature. When you want to add something, you only pick and choose whatever you want. For example, if you want to work with a fragment, you only include the fragment artifact, or if you want to work with SQL, you include the SQL. And the core KTX is for everything that doesn't have, it's not so big that it has its own artifact. Okay, let's get our hands dirty and see some code and see also some functionality that KTX can add to your source code. For example, extension functions. Maybe many of you know what is an extension function, but an extension function is a way to add a behavior to an existing class without having the source code. For example, here is the same utility class that we use, but right now we are using it directly on the objects. And in the bottom part is the behind scene, is the extension function, and as you see, it's wrapping the utility class. The structure of an extension function is like a normal extension, just we add the function keyword, and after that the name of the class dot the name of the function. Let's see. Also, another great feature that Kotlin has is operator overloading. An operator is like, you know, equal plus, minus plus. You can give a custom behavior to that, and KTX add a lot of this operator to some Android APIs. This example here is an example from the view group, and I really like this one because, for example, we have a view group, liner layout, and look how we can add ambient. Just plot plus add. Nice. And also, we can access this object like array. We indicate the position, and we can access the first one. And this one is another operator, is in. It's like contain, is asking if this object is in the view group. And the one that I really love is this one, this baby. You can iterate over this view group in a very nice way. And the last one is just minus equal. It's just removing the object. Let's see how it's it from behind. It's pretty similar to a common extension function. You only add the operator in front, and it's practically an extension. Here you can see where we are adding each one of the lines that we see before. The get, the contain, plus assign, and the iterator one. If you see, the iterator has a lot of code and is saving us a lot of noise in our code base. Let's go ahead. Also, there is a great functionality that Kotlin gave us. This is the destructuring declaration, and it is a way for break down an object in different variables at once. Here, for example, a color normally is composed by different variables, like red, the amount of red, green, blue, and also the alpha. But with destructive declarations, we can initialize all these variables at once in just one line, just using the object. As you can see here and below, this is what it's doing for generating this code. For creating a structure, we just have to do like we are using operator, and we add, after the class that we want to add the structure, we add the name of the we add component, and for example component 1, component 2, component 3, component 4. Each component is the position of the variable. For example, in component 1 we are getting the amount of red. In component 2, the amount of green, and blue is the 3, and so on. But the idea, if you change the order in how you are putting the variables, is going to get a different value. For example, if we put the green in the first place, the variable green in the first place, we are going to get in green the value of the red. It has to be in order. And let's see also other functionality that I like about KTX. This is a shared preference. As you know, shared preference is not so pretty to use, but KTX make it look beautiful. For example, if you want to edit a shared preference, you take advantage of the syntactic sugar of Kotlin, that if the last parameter of a function is a lambda, you don't have to put the parentheses. And for example, here we have a lambda, and all the operations that we are doing is operating on this preference. And this is adding extra code to apply. Apply is asynchronous and is not blocking the main thread. And the next line, this is an overloading of the same method, but we can tell I want that this code blocks, and we send it the parameter true, and we say okay, block this code, and this is and this from behind calls to commit. Instead of apply, it calls to commit. Also, maybe you are thinking, okay, I have heard about Enco. Enco is a little bit similar to KTX, but it's not equal. Why? Because under KTX they are looking for makes the Android APIs beautiful from Kotlin side. but they are not trying to add new functionality. If it is not in the Android APIs, they are not going to add it. But Encode is different. It's from the JetBrains box, and they are open to add new functionality. Like they have the layouts that you can do without XML, and you can do it just like a DSL, and the code routines too. And this is everything. Here are my contacts, and also I forget to mention that I'm writing for Grade Wendellich, and I also made an article about the same topic, and it will be available in a couple of days. And if you want some Kotlin stickers, I will be around. Just grab one.
And say hi. Getting so much free swag.
That's awesome. If you have any question, I am tiny.
I saw alpha in the release.
Yeah.
Is that well? What's the status of the?
For example, it's alpha because they are open to. It is an open source project. It's on GitHub. You can make a collaboration. You can send a pull request. But they haven't fixed the API. They haven't closed the API. It has good quality, but the API could be changed because they want input from the community. If they are open to whatever of your contributions, or if you think something could be changed, you can submit a pull request. Any more questions? I have some stickers. Yeah.
Like whenever you want to use KTX in a class or whatever, do you just import it like right in one import line, or the whole?
Yeah. It depends really of what do you want to use. For example, if you just want to use fragments, you want to have a better API created for Kotlin's Kotlin language. You only include the fragment. But the idea is that you have autocomplete. If you, for example, just want to, you are looking for a functionality, you just type dot and you start writing how the name should look, and it's probably that it appears in the list. And I'm not quite sure, but I think that Android can add a dependency, even though it can see some method. It can add a dependency, even though you don't have it added. Because I think that when you are in XML and you include a coordinator layout, even though you don't have it on your dependency list, it added it for you. I don't know if it does the same with KTX. Another one.